right. Is it just another buzzword? We love buzzword. We pretty much dream of one every 2 seconds. But the truth is, the word observable system or observability is actually nothing new. It was actually coined by Dr. Coleman in his paper about general theory of control system. In here, it said, a system is observable if the behavior of the entire system can be determined by only looking at its inputs and outputs. Pretty simple, pretty easy to understand. Let's put it in our context. It means that we should be able to understand our application without knowing the inner, how it really works and how it really talk together. We can just understand it by looking at the input and output of the system. Now, at this point, you might be thinking, oh, I'm stepping into a talk about logging and metrics again. How boring is that? Well, maybe, actually. So let's not answer that yet, because I think Andrew has a story to tell.
So I'm going to tell a story which sort of reflects my journey in the industry over the last 10-ish years. So this is indicative generally of enterprise environments, but you could tell a very similar story in a lot of startups that I've worked in and around. So hopefully you'll be familiar with some parts of this story. So our journey starts with an app. We've got an idea, and we've knocked up a quick prototype. We've got an app running on a host, and we've got a database running on a host. Things are good. No one's using it, but we've got something out there that we can test with customers, be they external customers or internal customers. No one's using it, so we don't really have any particular concerns about availability. If something goes wrong, we can sort of log on to the box and just debug it. When people actually start using it, and now we've got to care about this thing being up and working, we might bring on some infrastructure folks to help keep the systems reliable. I mean, a long time ago, we didn't call them SREs or anything like that. They were just sort of infrastructure or ops people. And a lot of the ops people I worked with, they love Nagios. So we might start shipping some host metrics, CPU, load, memory, like disk I/O, all that sort of good stuff off to something like Nagios. For alerting, for dashboards, for stuff like that. And we've got our devs building an app, we've got our infrastructure folks hitting, shoving metrics into Nagios, but no one really cares about the customer end view yet. No one's really looking after that. The business keeps growing. We've got more and more people using this. So we've had to get our developers to start, to fix all the bottlenecks that prevent us from spinning more of these things out into a sort of horizontal scale. And we've worked on clustering our database. So we've got a bunch of virtual machines kicking around. And it's getting too hard to log onto a single machine now to figure out what's going on. So our devs really want some way to be able to query logs, essentially, to find out where an incident has gone wrong. So we've got our friendly infrastructure folks to stand up an Elasticsearch stack, and we're going to start shipping logs off. We're just dumping logs onto a file, and the Elastic stack sort of picks them up and ships them off. And we're sort of happy, but we also realize how awful logs are to deal with for trying to resolve an issue. Because typically logs, they'll write stuff in human readable format, which is actually really hard to query. Like I've done a lot of sort of personal work on natural language processing, and it is not easy to apply that stuff to logs. No matter how many fancy providers we have out there, it's still a crap format fundamentally. Like we're still working with that and trying to debug using this. And other sort of ecosystem-specific things around here with Elasticsearch, if you want to be able to query the data differently in a slightly different way, you've got to go and poke the infrastructure folks and get them to update your indexes, and we all know how much fun that can be. So now we've sort of learned from our infrastructure people that it'd be good to have some metrics to understand in a bit more detail what's happening. So we've found out about this cool thing called StatsD. We've sort of spun it up, and we're going to start instrumenting the app all over the place, and it's going to start shipping out some metrics. So we've now got 3 interfaces into our system. We've got our infrastructure stuff, we've got our logs, and we've got our metrics. And they're all slightly focused on different things. And what we're really starting to see here is the beginning, or the sort of middle, of the DevOps responsibility split. We've got ops teams responsible for some stuff, we've got devs responsible for other stuff, and we've really got no single vision for how we should be supporting the customer. There's no one focused on that sort of customer happiness. One of sort of the leading lights in the observability movement, Charity Majors, has a great quote, which is, she says it's possible to have 5 nines of availability, but you can still have some really pissed off customers. I think that it really is representative of this sort of DevOps sort of traditional responsibility split. So we move on a bit more. We have tools like New Relic emerge, which are great because we can just drop a thing in a new package in our app, and we start shipping a whole bunch of metrics. And we're like, this is great. We've got insight into some of the things we've never had before. This sort of application performance monitoring movement is really great, and we're starting to see customer-focused metrics, which is pretty awesome. And we're also, this sort of enables us to start moving to the cloud. About this time, sort of in my career, AWS landed in Sydney, so the rest of my career was focused on getting stuff onto AWS. So it means we can start spinning up EC2 hosts, we're putting our app, just dumping it up onto the cloud, and it's shipping up to StatsD and Elasticsearch, and Nagios is over there somewhere, because we still, our infrastructure folks still want Nagios hooked up to the new EC2 instances, and we've got New Relic over here. So now we've got 4 interfaces, and every time something goes wrong, I've got to look at 4 different places to find out what's going on. And trying to correlate across that, it's starting to get a bit old and not super fun. So then we find out about this great tool called Splunk, where the infra folks hate managing Elasticsearch. It is an absolute beast. I've done it. It is genuinely one of the more difficult tools to run. And no one's looking after the StatsD server anymore. Splunk can apparently do all of that, so we're just going to move everything across to Splunk. Everything's in Splunk. We're really happy. Now we've only got 3 things to look at. But we've fallen afoul of this sort of syndrome. It's one tool to rule them all. Particularly in our infrastructure world, we're beholden to this culture of monoliths. In the sort of development space, we've moved well out of that, and now we've realized that we need things to be able to adapt and change at different rates, but not in our operations. We've got lock-in, it's slow and hard to change. Every time we want to change a tool, it's a massive re-engineering effort that might take several years. And it gets kind of painful. But we do it, we eat it because we have to. So we're using a lot of Splunk. We're starting to spin out microservices now because we've heard about this new thing. New Relic's still working well for us because we can still drop it in these microservices and they push stuff out. Nagios is still hanging on out there. We're making heavy use of Splunk, but our management has come back and said Splunk is too expensive, so we're going to turn it off in dev. We're not going to log in dev. We're going to only log sort of error level things, and now we can't see what the hell is going on. So we're full steam ahead with our cloud journey now. We've shoved everything onto Kubernetes. We've still got New Relic hanging around. We've got plenty of databases kicking around, and we're shoving everything into CloudWatch just because that's kind of easy. We've had to, we've re-engineered everything. We've had to update packages across the whole fleet, but it cost a lot of engineering hours. But we're all in CloudWatch and we're all happy, sort of. And we need our alerting to come up to scratch now because we've got this is a very popular service now. We've got a lot of high influence customers using this thing, so we want to know if something goes wrong so we can get on top of it. But the other thing that is pretty awful in this space is the developer experience or the engineer experience, because it's not just developers, it's engineers. Some of this stuff is genuinely awful to use. The last project that Inny and I worked on together, we had to integrate CloudWatch to PagerDuty. Most of the time, I want to write about this much code, on this condition, alert me on my sort of preferred alert systems. But what we typically have to do is about this much stuff, which is kind of absurd. And this is the clicky version. It's several. I have to deploy several CloudFormation templates and like hope that PagerDuty picks them up. And it shouldn't be this hard. I just want some alerts. I want to know when something has gone wrong. So we finally get through all of that. We've realized that CloudWatch is a crap interface for searching through logs and metrics. So we've hooked up something like Sumo Logic. We're still using PagerDuty. We've realized that Kubernetes can give us more, like the tool de jour, Prometheus, which is actually kind of good, but it's yet another interface. So we've got New Relic, Prometheus, PagerDuty, CloudWatch, and Sumo Logic. We've got so many different panes of glass that we have to look at. And what kind of one thing in common across all of these tools is dashboards. And I don't know about you, but when I'm debugging an outage, dashboards are useless. Like they can tell me about something that I already know. If I've got an outage that we've never seen before, dashboard is not going to help me. These tools produce beautiful dashboards, but I can't query through them. I'm kind of having to use my own intuition. And if I haven't been in the project long enough to know where the skeletons are and where they're causing problems, it is an absolute nightmare. And this is kind of where we get up to. And at this point, I'm ready to flip over a table and walk out. And this has happened to me on several occasions in the last 12 months.
So hopefully this all sounds a little familiar. I saw some head nodding. I've definitely experienced something similar throughout my career. And I think the way that we build system today and also provision our infrastructure today, it's quite different now. We have evolved quite a fair bit in our industry. So instead of monolithic, nowadays we mostly build what we call microservices. And in terms of infrastructure, instead of a static infrastructure, we usually use dynamic infrastructure, so in terms of cloud. And interesting enough, the rise of cloud actually accelerated adoption of microservices. So now, when we look at observability, we have logs and metrics, and is that still works in this new world? Well, I think from the story that Andrew told us, I would say that I don't think it really works nowadays. Imagine you get a pager at 2 a.m. in the morning in this cold Wellington morning, and all you face is that set of tools that with all these different interfaces, you're trying to remember how to use this particular special query language. How is this set us up to success to reduce our mean time to recovery, which is an important metric for happiness of our customer? Why are we doing this to ourselves? We have suffered enough as an industry. We can do better than this. There's something that we need to do in order to make our life better, especially when it comes to on-call. On-call is still an essential thing. And we need to do something to make it better, to make it great and more fun. With the tools that we have today, we're basically walking into a crime scenes, a modern one, by the way, and all I'm given is a magnifying glass. So good luck to me to be able to solve that crime. So there's something that we've got to do. We have to fix this. And I think there's two main things that we're looking at here. So we have logs and metrics. They are both important. I love both of them, but they are separate. So I need to look at different system interface, need to correlate it myself, using my hand or paper and whatnot. So it's clunky, and I'm bound to have some sort of human error. And the other thing is what we described, there's a lot of things, information everywhere. There's multiple interfaces everywhere. So I want to talk about the metrics and logs first. And we are lucky enough that we are able to work in different domains with different people. So we like to take goodness that we learn from different people and apply it in infrastructure. So we've saw this thing called event-driven architecture. So just as a recap, what is it? So we have an event stream usually. You have a producer that produces an event. In this case, we're talking about business event. For example, you make a purchase. And then you have consumer that consume that events, they're interested about someone make a purchase, and I want to do something with this event. So looking at these, number one is a really good way to collect things. And the second thing that we notice is this thing called events. What we are thinking is, well, can we replace that with events, actually? So let's have a look. Well, with the scenarios like this, we have a customer with a customer ID trying to log into a system at this time on this date. It took the system 300 milliseconds, and it returned a 401. So what does it look like in an event? And metrics. So in terms of metrics, metrics is used to collect numbers, numeric values. In this case, it's obvious that we're trying to collect the request timing using metrics. Yes, we can actually make it more meaningful by adding tags. But then again, imagine having one tag for every single customer. It can go out of hand very, very quickly. So in terms of events, not only is it able to have the request time in there, it also has all the other important information that we're expecting in an event. Also, we have some unexpected thing there, like the API version, build number, environment, anything that you want to put in there, because it's just an event. How about logs? I mean, like, I know you're thinking, we can put everything in logs, isn't it? Yes, we can. We can put everything in that single log lines that we want to record or simulate what event does. But the other thing is, logs has a particular format that we're expecting. So when someone decided to change that format of the logs, your alert is going to stop working. Anything that dependent on that particular query for the logs is going to stop working. So in this case, events is a little different. It's just a JSON blob. It's digestible. You can add as many things as you want and remove as many things as you want. So what we are saying here is, we reckon event can use to replace logs and metrics, and it also allowed us to add a lot of different context to it, as much as you want and as little as you want. So just think about for your future self how much you want to add to it when you want to debug a system. So in this case, we're saying that let's use event, observability event, observable event. But then there still has this problem of having a lot of interface with information everywhere.
So one of the nice things about being a consultant is we get to work in a lot of different places, and that means we get a chance to work in teams that have a lot of different skill sets. One of the things, one of the gigs that Inny and I worked on recently was an event-driven architecture platform. So we got to see how experts with this start to use events, and it's sort of the sorts of things that we needed to manage that. We wanted to build a single place to access data from a huge array of sources. Like, that sounds like a good thing, right? We wanted simpler ways to get that data in and out, like into that central place. We wanted to make it easy for delivery teams to be shipping sort of business events. We didn't want any pre-aggregation because we didn't want to make any assumptions about how that data was going to be consumed. We wanted to enable data scientists to be able to slice and dice that data without any assumptions about how it's going to be used. It needed to be fast enough for querying, for ad hoc querying, sort of novel queries, maybe not blindingly fast, but fast enough that if you're a data scientist with a scent, you can follow that scent in a reasonable time. It had to be easy to create and evolve alerts and to ship them off to some kind of third-party system. We wanted like standard formats that could contain a myriad of information, with sensible defaults but not mandates for standard information. We want data pipelines because that's a good thing. It means we can ship data once and then change it, interpret it many times. And we wanted to start to move away from single tools. We wanted something that would help us change and evolve the different capabilities that this data platform needed. And then it occurred to Inny and I that all of these things would be really nice to have for our operational platform as well. If we had a lot of rich event data, we could just use existing tools from the data space to help us solve operational problems. So we thought, really, all this is just it's a data platform. we've solved all those problems in the data space, but we keep using, like, we're the cobbler's children in the operations space. We don't allow ourselves to have nice things. There are definitely plenty of nice things out there, but they don't work together. I have to choose one tool at a time. I can't. It's rare that I get to use a collection of the things that are really nice together. And we can take advantage of data patterns like a data catalog, so I can interpret other teams' operational data and merge it with my own. As we know in this massively distributed world, things make sense when they're working together. So if we can interpret other teams' data, then we've got far more ability to sort of leverage that data and create insights. And in sort of the customer big data world, we would never think about chucking data out. Like it is incredibly cheap to store this data to an extent. Like we might need to come up with crafty ways, but we don't throw out data that could be useful for some sort of future insight. So, like this kind of data platform architecture should give us things like evolvability, scalability, reliability, and integrity. The key thing here is evolvability, because one of the things that we always run into is the ability to change these things quickly. We find a new tool. It's a massive multi-year effort to re-engineer this, across our huge fleet of servers. So this, we really think just by stealing ideas from this other space, we can really help the growing complexity in the operations space.
So now it comes to alerts and dashboard. Are they still relevant? Yes, they are. In particular, when it comes to alert, in an event-driven architecture, it's pretty simple. All we really need is a consumer. So we can write our alert using code. And then we can just consume the events or the observability events that we want. And then we can just have a codified set of rules and policy that we want to make sure to define the health of our system. When they violate a policy, we just send an alert back to the event stream. Some other things can consume it, and they can do anything to it if they want. Send an email, build some dashboard, whatnot. So remember that example that Andrew talked about PagerDuty, clicky? Just imagine we can just do it on code. This is just code. And what it means is that we can use all the goodness that we do with code, we can do TDD with it. I remember someone asked me, I created this alert, I have this query, how do I test it? I'm like, well, we can just run the query, but at the end of the day, we have to deploy it and fake a particular error and hope for the best. But in this case, this is just code. All we really need is write some unit test and test it. So do we still need dashboard? Well, this is an interesting topic for me. I really love dashboard at one point of my life, but then I think someone asked me the question, it's like, well, I mean, if everything is green, why do you want to know? You only want to know it when it is red, and when it is red, you should get an alert. So what's the point of a dashboard? And I'm like, well, okay, you have a good point there. So I would say, personally, I would rely more on alerts rather than dashboard.
One of the things we do know from the data world and from just running operational platforms for a long time is that the strength of it only comes from the quality of the data. So there is no magic way to get data, but we need a lot of it somehow. Fortunately, there are a lot of approaches that can help us get the data. We can use we can have libraries, we can do auto instrumentation. Like there's a lot of patterns and practices we can pull from sort of prior art because we've been evolving this space. How do we get a lot of insight into our running systems without having to write a whole pile of code? But there's also, I think that will only get us part of the way. As devs, we want to enable a world where we can essentially debug an incident we've never seen before without having to write new code. So the only way we can do that is by sort of taking as much care with our observability code as we do with TDD. With TDD, we're sort of designing our code around the way it should work. So that at every point where we write a test, it's also probably a pretty good point to write something that generates insight about how the code is running. And if we do it if we write a little bit extra code when we're doing TDD, we can pretty much instrument just about anything in the code, and it gives us really, really good coverage. It's almost like switching to a debug first mindset, which I think is what really sort of kicks this up a notch. And we are sort of wanting to do ourselves, like our future selves, a favor. On that 2 a.m. on the cold Wellington morning, we don't want to have to deploy something new to figure out what's gone wrong and hope that it works.
So, what we want to do is we want to remove everything. We want to use event-driven architecture, sending event to event streams, use kind of data world of things, put everything into a data lake, and then use consumer as a way to do alerts. So just quickly run through an example. So this is using Jupyter Notebook on BigQuery. I can go through it a little bit more later. We're running out of time. But then basically, we do a very simple query. We found that something is wrong. We got all the data there. We do an extra query on some other data. And then I can go through that when you folks want. We are out of time, unfortunately. Yep. And then what we found is we actually have a new version of a particular service that actually got deployed. Therefore, things started to go a little slow. So what we believe is everyone can be a superhero and everyone have that superpower in them. And we think that by adopting this similar approach will allow us to unleash our superpower.
So we started out by, the title of this talk is Observability for Everyone. And even this concept is not new. Sort of charity majors and the Honeycomb folks have been saying this for a long time. But we feel that an architecture like this really does open it up to everyone, because we can take the tools that folks have been using in the big data space and apply them to our operational needs. But it also opens up like a wealth of use cases outside of our devs and our ops. So our security folks can listen for events and apply alerts. We can have our products and sales people be listening for particular events. One of the really nice sort of side effects of this is we could almost replace something like Google Analytics with a privacy-preserving way of doing it. So there's a huge potential in this system to open up observability for genuinely everyone. And with that, I think we'll be done. Thank you very much. Cool, yep.
Just one comment. I don't believe what they said. You can actually go to Expedia has a project called Haystack, which is basically an implementation of exactly what they described, an event stream-based observability platform. So you can take a look at something that you could actually run without writing the things, and also write the things if you like to. But it's microservice-based. It's basically an implementation of exactly that presentation. Good job.
Awesome. Thanks. Thanks, everyone.
Thank you.